All right, and we're back for another lesson here. And today, what we're going to focus on in this particular lesson is distance between 2 points in the coordinate plane. So last time we talked about the midpoint, all right, between 2 points. Now we're going to find the distance between those 2 points. And it comes back to something that you probably have known for a while and that you've used, all right, is the Pythagorean theorem. Now, once again, this is very blurry and everything, so we're just going to skip that for now, and we're going to go right to the vocabulary, and then we'll get to some better examples about how to find the distance. So let's talk about, all right, distance. All right, so distance, all right, is the length of a segment. All right, so the length of a segment, and let me look right over here. I want to make sure if I don't leave anything out. All right, the length of a segment, all right, okay. And so when we think about a segment going from A to B here, all right, this, right, is the distance, right, that complete length, all right, from there to there, from endpoint to endpoint, or from point to point. All right, so now when we think about the hypotenuse, and we're going to talk about the hypotenuse in the Pythagorean theorem, is that the hypotenuse only occurs in a right triangle. All right. So, and I drew the diagram here, but the hypotenuse, all right, is the side opposite the right angle in a right triangle. And so I kind of put the diagram and the definition all together there in one particular piece. All right. So that's okay. But we have to know what that is, because when we use the Pythagorean theorem is a squared plus b squared equals c squared. So when we think about our right triangle, all right, c is always the hypotenuse, and all right, then a and b are the two legs. And it doesn't matter which one is which, right? So a and b just represent the two legs. So one is the vertical leg, one is the horizontal leg. All right, so that's some of our basic, all right, terminology and vocabulary that we're going to use for distance here. All right, so now when we look at the next page on 15, all right, we want to, all right, find some lengths here. So notice we want to find the length here, all right, of AB. We want to find the length of AC, all right, and then we want to find the length of BC right here. And you can see that we have a right triangle, because anytime we have a horizontal and a vertical line, we know that they're going to be perpendicular, which is going to create that 90-degree angle, all right, which gives us a right triangle. And notice, if I'm going to find the distance of AB, all right, this is pretty simple because I can just count, right? So, and notice my scale goes up by 2, so there's 2 to 4, all right? So this has a length of 4. All right, here I can just count horizontally, and that has a length of 3. But notice this is why we need the Pythagorean theorem, because notice I can't count, all right, those blocks because I'm on a diagonal here. All right, so because I'm on that diagonal, all right, I need a tool. All right, and that tool, all right, is a squared plus b squared equals c squared. All right, so because it's not a horizontal or vertical line, we need another tool. Anytime you have a horizontal line or a vertical line, you can just count. All right, count those boxes and you're good, right? All right, so when we think about our Pythagorean theorem, right, so a squared plus b squared equals c squared, all right, so I always think of a as my horizontal change, all right, so like in this case, that would have been 3. I think of b as my vertical change, all right, and that would have been the 4 that we saw here. All right, and then C, this is the length that we're looking for. This is the distance, all right, from B to C, or you can think of it that this is the length, right, of BC. So distance from B to C, or the length of BC. So kind of just either way you want to think about it. All right, so what we want to do to use the Pythagorean theorem, right, is we want to think about our points, right, all right, and so we want to find the horizontal, all right, and vertical distances, which is basically what we did above, right? All right, creating our right angle. And once again, if I'm going too fast, you can kind of listen and watch me write, and you can pause the video and then fill in your notes if you need to, or you can kind of pause and listen, all right? And then we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared, to solve, all right, for the missing distance, all right? If we, and like I said, if it's not already horizontal and vertical. All right, so let's look at our example here, all right, that we have, all right, and we want to find the distance between negative 3, 4 and 2, 3. So negative 3, 4, once again, this is not a great graph here. So negative 3, 4, so 1, 2, 3, 1, 2, 3, 4. So there's negative 3, 4. All right, and I'm just going to maybe darken in our axes here. So there's the vertical, there's the horizontal, and then 2, 3. So 1, 2, 1, 2, 3. All right. And so really what we want to do is think about this, that we want to find this right here. This is C. That's our distance, that guy right there. And so what we want to do is really think about our right triangle. So if I draw in my vertical length and I draw in my horizontal length, I create that right triangle. And I'm just going to recreate it right here, since that graph is a little hard to see, and we're looking for that right there. So if I look, my vertical here has a length of 1. My horizontal, so 1, 2, 3, 4, 5, has a length of 5. And you can kind of see that as we look here, because if I go from negative 3 to 2, I went to the right 5. And I went from 4 to 3, I went down 1, right? So you can see that that's a length of 1. And so now what I have is I have my vertical and my horizontal change, so I can just put those into my Pythagorean theorem. So I would have 5 squared plus 1 squared equals c squared. And then I go, and this is 25 plus 1 equals c squared. And then this is 26 equals c squared. All right. And then let me grab my calculator, because we know from, all right, what we've done in algebra, that to solve for c here, we need to take the square root of both sides. All right. And then if I take the square root of c, or c squared, on my calculator, that'd be the square root of 26. And that tells me that it's about 5.1 units in length. And that's really, all right, your distance formula. All right, so let's go through maybe one more example here. All right, so let's go ahead and flip over to page 16 here, and let's look at that. All right. And so once again, we will find the distance between the 2 points. And so this is the distance that I want to find right here. All right, so that's the C, right? And then once again, what we want to do is create our right triangle. So we can draw in our vertical and horizontal legs, all right, into this triangle. And once again, that creates that right angle there. And we can see that our vertical leg here has a length of 1, 2, 3, 4, 5. All right, and we have a horizontal length of 2. And so once again, if we think about a squared plus b squared equals c squared, all right, these are my 2 legs, so this would be 2 squared plus 5 squared equals c squared. All right, so that's 4 plus 25 equals c squared, which gives me 29 equals c squared. And then once again, we just want to take the square root of both sides. And if I do that on my calculator here, square root of 29 is, all right, 5.4 is equal to c if I round to the nearest tenth. All right, so that is how, all right, we find distance. All right, so I'm going to leave you to finish the rest of your notes. So you have 2, 3, and 4 here. All right, and then you have, all right, 5, 6, 7, and 8, all right, to finish up. And I will see you next time.